Hey everyone, welcome to the sixth video of JPA Hibernate series. If you haven't checked out the previous videos of the same series, please do so. You can find the playlist here in the playlist section. And if you check out the playlist, these are the 5 videos that you should see. As for this video, we will talk about embeddable annotation, which is a JPA annotation. So we will learn in what scenarios we can use this annotation. So without further ado, let's get started. In the real projects, generally we already have the database, we have the existing tables, and we have to develop the application on top of that. So we will take a similar approach. We will assume that the tables are already there in the database and we have to develop an application. We have to model the entities according to the existing tables. So in this hypothetical scenario, there are two tables, user and audit. For the user table, we have the user ID as primary key. Then there are several columns like name, email, city, state, country, and address. Similarly, for the audit table, we have a primary key with the name ID, and then again few columns like title, code, audit city, audit state, audit country, and address. So as you can see, both the tables have address details. That means the corresponding address will reside in the same table. User table will have its own address and audit will have its own address. They are not sharing their addresses. So the address information is saved within the entity or within the corresponding table. So let's stop for a moment and think, how can we write the corresponding JPA or Hibernate entity in this case? It looks pretty simple because there are two tables, so we can write two JPA entities, annotate them with @entity annotation and other required annotations, and we can simply insert the data. So we can come up with two entity classes, something like this: public class user, public class audit, and the corresponding classes will have the relevant fields. So for example, for user table, we can have the user entity, which will have the user ID, user email, city, state, country, address. And in the same way, for the audit table, we will have the audit entity, which will have fields related to audit table. And then using, let's say, the corresponding Spring Data JPA repository, we can simply save the data into the database. That will work perfectly fine. But as soon as we write this, the Java developer inside us will notice that we are kind of duplicating the highlighted fields, which is address related fields, city, state, country, address. And similarly, here we have audit city, audit state, audit country, and address. So can we avoid this duplication? We might think, what if we create or extract all these fields to a different class, let's say public class address? Because in a project, there could be multiple entities which might have the address information. So what if we have an address class that we can reuse using composition or aggregation in Java? There is no difference. But what if we can use the same address class wherever we need the address information? But if we do this, there are two challenges. Number one, how do we actually do this? And number two, each table will probably have different column names for address details. For example, in this case, audit has audit city while user has simplicity. So how do we reuse the same set of fields for different tables in different entities? That's what we will see in this video. We will learn how can we use embeddable annotation in such scenarios to reuse the existing fields. So let's move on and start with the coding. We'll use Spring Initializer to set up a new code for this demo, and because we are using Spring Data JPA with Hibernate, we'll go with a Spring Boot project. So that's going to be a Maven project for me. Java, this version is fine. Let's fill in the details. JPA with Hibernate and jar JDK 17, it's fine. Because I still have JDK 19 on my system, so I'll simply go with JDK 17, but you can choose 21 or 22, it doesn't matter. As for the dependencies, we will keep things simple. So let's add required dependencies. First one is Lombok. You don't really need one. I'm just going to use it to generate the getters and setters. The important dependency is data JPA and the database driver. Because in my case, this is MySQL database that I'm going to use, so I will use MySQL driver. In your case, let's say you are using Postgres, then add corresponding driver and then generate the project, and we'll open the project in the IntelliJ. All right, here we have the unzipped folder. Let's open it with IntelliJ. And while it does, in the meantime, let's open the MySQL. So as you can see, my MySQL workbench, it has existing connections for different demos. So let me create a new connection for this one. We'll give it a name. Let's name it JPA with Hibernate test connection successful. So we can simply go ahead and here we will now create a new schema. So let's create a new schema, give it a name. We'll say JPA with Hibernate. And as you can see, this is the new schema that we just created. It is empty right now. There are no tables, but as we go on with the demo, we will have tables in this schema. So let's move ahead and see if the IntelliJ part is complete. So here we are. It is downloading the dependencies. And in the meantime, if we check the pom.xml, we have all the required dependencies. So we have Spring Starter Data JPA, we have the connector driver and Lombok. That's all we need. Now that we have all the required dependencies, it has downloaded the dependencies. Let's start with the coding itself. So first of all, we'll go to the application.properties. Here we need to define some properties in order to connect with the database. So first of all, let me rename it to YAML file. It's not required, but I'm just going with the YAML file. All right. So what are the required properties that we need? First of all, we need to provide the database information where the database is running so that the application can connect. So this is spring.datasource URL. That's the first one. Then we'll provide the username, then password. Username in my case is root, and I will provide my password. In your case, you need to provide your username password for the database. As for the URL, we need to provide the path of the database. So this is going to be jdbc:/mysql localhost 3306 and name of the schema, which is JPA with Hibernate. Then we will also provide a couple of JPA related properties. The first one is show SQL. We will use this property because we want to see the queries generated by Spring Data and Hibernate at runtime so that we know what is happening behind the scene. And the second one is under Hibernate DDL auto, and we will use for now create. So what it does, this property enables Hibernate to generate the tables or all the missing tables at runtime. As you know, the database is currently empty. There are no tables. And if we set this property, what it will do when we run the application, whatever entities we define, Hibernate will see if the corresponding table or the construct exists in the database. If it does, it will simply ignore that thing. If it doesn't, it will create all the missing tables that it needs in order to proceed. So that is fine for the local development or for the demo purposes, but we don't use this property in the production. In production, we already have all the existing tables or whatever is required for the application to work properly. So we don't need to set this property in production. Anyway, let's move on. So we have defined all the required properties. Now we will define the entities and the required repository so that we can work with this demo. Here we have the main class, which is annotated with Spring Boot application, and it has the main method. So first of all, let's define a new class, which will be our entity. And this will be in entity folder. We'll name it user. Why user? Because if you remember, we have two entities. So if you go back here, we have two tables, user and audit. So there will be two entities as we discussed. One is for user and another one is for audit. So let's start with the user first. We know we have to annotate it with @entity. So Hibernate knows that this is an entity which will be managed by Spring Data. All right. And then we will add the required properties. So first of all, we'll add the ID, which is user ID. Then it was name, email, city, state, country, address. Okay. Name, email, city, state, country, and address, right? And we will also use one of the Lombok annotation so that we don't have to generate all the getters and setters, which is the data. So it will now generate all the required getters and setters. Then for the ID attribute, we need to use the ID annotation, and it will be auto generated. So we use @generated value annotation. Now the user entity is mostly ready. Let's do the same with audit. So we'll add a new class, audit, and we'll do the same thing here. @entity, @data from Lombok, and the primary key, title, or was it code? It was code, title, code, city. Okay. And then we'll copy the attributes from here. So as I copied the attributes, realized that this is already a duplication. That's why I had to copy paste. Audit city, audit state, audit country, and audit address. So we have both the entities ready. How do we use them now? Because we are using Spring Data JPA, we can use the repository model. What it means, we will create some repositories, basically interfaces, and Spring Data will generate the required code. And then we can use those repositories for CRUD operations. So let's do that. We'll add a new interface in the DAO package. And first we need a user repository like this. This will extend JPA repository, and it has two type parameters. First one is the entity class that you are managing. So in this case, this is user. And the second one is the data type of your primary key. So in our case, this is long. If you go to the user entity, you see this is the data type that it needs for the primary key. All right. And that's the only thing it needs. Let's do the same with audit. So audit repository. It will also extend JPA repository, and in this case the type of the entity is audit, and the data type of the primary key is long. That's all. So we have the entities, we have the repository, Spring Data repository for the entities. Let's now go to the main class and we'll try to run it. So in the main class, what we will do, because we don't have any endpoints exposed, this is not a web application, and so we'll keep it simple. We'll run it as a command line application. So what we need is, we need an application runner like this. And this will be a Spring Bean. And then what we will do, we will inject the classes, the required classes here, so that we can use it when we run the application. The required classes in this case are user repository and audit repository like this. So when we run the application, Spring Boot will see we need an application runner, and it will create this bean, and at the same time it will find the user repository and audit repository, and it will inject these two beans in this method. So you can see this is kind of auto varying, where we are injecting the required objects, and once we have the required objects here, we can access them. So first of all, let's try to save the user. user u1 equals to new user. All right, and then we need to set all the properties starting with the name. We don't need to set the user ID because it will be auto generated by Hibernate. So we need email. All right, then we will add the address details. So let's start with city, then state, then country, and then address. So this is a new user and we need to save the user. So what we will do, we will use the repository. It has a save method that can save the user entity. That's all we need. All right. Everything else will be taken care of by Spring Data JPA. And similarly, we'll add a separator and we'll do the same thing with audit. A1 dot set title. So this is demo audit. Then we need the code. Let's say this is 101. Audit city, audit state, audit country, and in the end, the address. All right. And similarly, we will use audit repository to save audit entity. Okay, so let's quickly revisit what we did. First of all, in the application file, we provided the required details. These are the required details. These two are optional, but we need them for the demo. Then we created the user entity and then the audit entity. I missed it. It must be ID and generated value. All right. And then we created the user repository and audit repository. And in the main class, we are injecting the user repository and audit repository. We are creating the user object, saving it using user repository. Similarly, we are creating the audit object and saving it with audit repository. So let's now try to run the application. And if everything goes fine, we'll have two tables in the database. And these two tables will have one record. So if we check the logs, in the logs, we see two insert queries, basically in the user table and in the audit table. That's what we expected. If we go to the database and if we refresh the schema, now we have two tables. One is for audit and another one is for user. So let's see. In the user table, we have the user with the user details, and in the audit table, we have the audit details. All right. So for now, we have simply created the entities and added them in the database. We haven't done anything related to embeddable annotation that we discussed. So if we go to the entities, we know we see some duplication related to address information, and we thought, how can we avoid this duplication? Can we create a separate class, a separate model that can be used wherever we require the address information? And if you remember, this is what we discussed to create an address class. So we want to extract all the address details to a different class that can be used anywhere we need the address information. So let's try to do that. Let's create a new address class. Now notice we won't annotate this class with @entity annotation because address doesn't have its own table. It's not an entity. Otherwise, what Hibernate will do, Hibernate will create a separate table for the address. So in this case, when we are extracting the details from user and audit to this class, we are only changing the object side of ORM, not the database side. So in this case, address is a plain simple class which holds the common attributes related to address. It's not an entity, it doesn't have any table. So we don't need to use @entity annotation, but we still need getters and setters. So for that, I will use @data annotation. And then what we will do, we will copy all the address related fields, basically cut and paste it here. Now we have a separate class just for the address. And let's say in the user class, we need the address details. So we will simply use the object here. And this is plain Java. That's what we generally do when we have kind of a composition. All right, let's do the same thing with the audit table like this. And if you go to the address, we also need to add a new annotation here, which is embeddable. Now this bit is important. This annotation tells JPA that this class can be embedded in an entity. And that's what we are doing here. We extracted the address details to this class, and now we want to embed this particular class in user and audit entities. So that's why we need to add this @embeddable annotation. And we also need to change the getters and setters here, because now we need to create the address object. So let's do that. Address, we will say user address, and instead of u1 we need to set the corresponding details of the address like this, and in the end we will set the address to the user class like this. And similarly, we need to create a new address object for the audit. And in the end, we will set the corresponding address to audit address. Now, the first thing that you must notice is the properties are different now. Earlier, they used to be audit city, audit state, audit country, and audit address. And it's not just the Java side. If you notice in the database, we have the columns like audit underscore country, audit underscore city. And here we are assuming that these tables exist. In a real project, the tables will already exist, and in most cases, we can't really change the database schema or database structure. We have to work with the existing structure. So this is the one thing that we will notice. Let's see when we run the application, how it changes the audit table. So for now, let me change the properties. This is simply set city, state, audit, and address. Okay, let's rerun the application now. So the execution is complete. There are no errors, which is good. That means we successfully use the embedded or embeddable annotation. Let's check the database here. We'll refresh. And in the user table, let's first check the user table. So in the user table, we don't see any change. All the columns are still city, state, address, and country with the corresponding values. And if we check the audit table, this changed now. We see the columns are changed now. Earlier they used to be audit underscore city, audit underscore address, but they are now simply city, state, address, and country. And the reason is because we are using this entity address class basically, which has these properties. And when we use it in the entity, Hibernate will generate the column names with the same name. That essentially means in case the tables are already there in the database and we don't have this property set up, in which case the Hibernate will not generate the missing tables. And if this is a real project, then this would fail because it will not find the matching columns. When it saves the audit, now because of the address class, it will look for columns like city, country, state. But in the database, in the audit table, there will be columns like audit underscore city, audit underscore state. So when we have a common class, embeddable, how do we override the properties in case the target entity has different column names? So in case of user, the columns are same as the property, which means city, state, country, and address. That is why it is fine with the user. But in case of audit, the columns are audit underscore city, audit underscore address, and so on. So it will not work with audit in this particular case. So to solve this, we need another annotation, which is attribute override. So when we have similar scenarios where we have another class and we want to override certain attributes, maybe we want to rename the property because the corresponding column name is different in the database. In such cases, we can use attribute override annotation. And in case there are multiple properties that we are going to override, we can also use attribute overrides. So let's use this one because we need to override all these properties as per the table structure of audit. So we will say attribute overrides, all right, and this requires an array like this. Then first of all, to override a single property, we need @attribute override name. That is the name of the property that we want to override. So first of all, this is city. And how do we change them? Well, there is another attribute which is column, and we will use @column annotation. Name equals to audit underscore city. And similarly, we will override all the four properties: city, state, country, and address. So this will be audit underscore state, audit underscore country, and audit underscore address. So what we are doing here is we are using a common class for the address properties, but for the audit, because the column names are different, these must be audit underscore city, audit underscore state. So we are overriding the existing properties. All right. Now notice in the main class where we are creating the audit entity, there will be no change required. This is still going to be set address, and for the address, this is going to be set city, set state, and so on. The only thing is when Hibernate will save the entity, it will see that it is using an embeddable class, which is address, but it needs to override the existing property. So when it saves the audit data, it will simply change all these properties to corresponding column names that we have provided here. So let's give it a try again. And this time you see an insert query in the audit table and it has different columns, audit underscore address. This is the expected outcome. So let's go to the database, and if we reselect everything, we won't see any change in the values, but the columns name would change: audit underscore state, audit underscore country, and that's what we wanted. So that's how we use @embeddable annotation to extract common details and basically to use composition or aggregation on the Java side. All right. And in case the column names are different where we are using this embeddable class, we can always override the attributes using attribute override annotation. So that's all for now. See you in the next video. Thanks for watching.